Okay, so I'm going to record this session. Fine. So let's begin then. So tell me what you have studied there in this pre-class activity. What is it about?
It's about maximize and minimize.
Okay, maximize and minimize something. Okay, this is one thing.
Objective.
Yes.
To explain the paragraph to simple
Mathematics.
Problems.
mathematics.
Okay, fine. Okay. So we say
How
that
to solve any problem by mathematics.
how to solve any problem by mathematics. So what we got, it is about maximize or minimize.
Yeah.
Okay, this is the first and the second thing. How to sorry, just help me, what was the second point that you have said?
About the objective.
How to
Objective.
how to find the objective function. Find the objective, we say. Objective.
And how to find the constraint.
How to find the constraints. Good. What else?
How
Someone
to
talked about
draw the
mathematical model. Someone talk about mathematical modeling.
Yes, how to take the words to numbers.
Okay, so that is what mathematical modeling, like use the information to you say form equation, form the set of we can say constants or equations. Good. So it means you actually gone through it and you understood it. So that's good. So yeah, this is what the topic is about. So this is the first unit of for this module, which is linear programming problem. So what you can see here is, just give me a minute. I think someone is waiting in the lobby. Okay. Okay. Ahmed, good evening. Welcome to the class. Next time, try to use your it's better if you use your MEC ID, then you don't need permission like now. What happened? I think he left again. Okay, so let's begin. So linear programming problem. So as the name says, it is programming. So here the programming doesn't mean the programming that we deal with computers. It's programming, basically we mean the modeling. Okay, so we are going to study about the mathematical modeling of the real-time situations and later on how to solve it. So these are the learning outcomes of this unit, and as you have told very correctly, what you have learned from the pre-class activity material is about the modeling, that is also known as the formulation of a linear programming problem. So we can say either as a linear programming problem or a linear programming model. Okay, so you will be able to make this formulation only after you know about the basic assumption and the properties of linear programming. So what does it mean? What does it mean? That at least you are, how do you know that this is the objective function? Means how do you know? What is the objective function? What is maximize or minimize? What do you mean by constraints? So these are the terms. So to come up with those things, we have used some terms over here. So what is it here? So first of all, as I said, linear programming. We studied linear programming, which is nothing but the mathematical procedure to determine the optimal allocation of a planned resources. So I believe you have seen it from the examples that there is a situation, one situation where you are going to buy some furniture within a specified amount of price or some specific amount of money that is available to you, or a person want to make trips to 3 or 4 places with the specific within a specific time and in the limited money to maximize the sale or something. So these are the examples. So this linear programming help us to do the optimal allocation. So optimal, so as you have said here, some of you said maximize and minimize, which is in general known as optimization. So we use the word optimization. So whenever we call optimization, it means we are talking about either maximization or minimization. Okay, so it is the optimal allocation of planned resources. So it is nothing but developing a mathematical model to represent a problem under the consideration. So let's quickly go through the components and then we will come to the questions. So you have seen that there are different components involved in the linear programming problem. So what are it? What are those components? First of all, the decision variables, the parameters, objective function, and the set of constraints. So how it is defined? Decision variables are the variables which are under your control, and then you are going to decide how much that should be there in the quantity or in the number. So the main highlight is these are the controllable inputs, whereas parameters correspond to the uncontrollable inputs which are not in your control, not under your control. Like suppose if you're going to buy something, the price of that particular thing is not in your control, that will be fixed. The only thing is in your control is how many you are going to buy. Like suppose if you're planning to go and buy a chair for a house, then the price of that chair will be fixed. Fixed in the sense, if you already planned that you want to buy a specific kind of chair, the price will be fixed, that you cannot change. So that will be the parameter. What decision will be in your hand? What will be the decision that how many chairs you are going to buy? 1, 2 or 3, depending upon the money that or the budget you have specified for that purchase. So that's the things known as decision variable and parameters. The difference is that decision variables are the quantities which are under your control, whereas parameters are the quantities which are not in our control. Then we have objective function. So that is clear that it is like you need to determine what is your purpose, what is your objective, what you wanted to do, what you wanted to achieve at the end. You want to maximize the quantity or minimize. So for example, if it is something related to sales, then you wanted to maximize the sale so that your profit will get maximized. On the other hand, if it is something related to purchasing, then you want to minimize the cost so that the things will come under your budget. So depending upon the problem, it could be a maximization or a minimization. Hence your objective function will be either maximization type or a minimization type. Similarly, the constraints are the restrictions. Like for instance, I gave you example that you're going to buy chairs. So what is the restriction? Your budget is the restriction. Okay. And the other restriction would be the space in your room for which you are buying the chairs. So we have these two restrictions for that specific problem. So constraints represent the requirements that should be fulfilled or the restrictions that cannot be crossed. Okay, so that's the reason it is called constraints, because we can say that it can be either less or maybe at most equal, but it's not necessary that it should be always equal. Like suppose you have 100 reals and you want to buy chairs, then it is possible that you spend 90 riyals and get all the chairs that you want, and you could save 10 riyals. It's not necessary that you will spend all of your money to get that thing. Okay, but the maximum limit is 100. So that's why it is known as constraints, because it could be an inequality or an equality. If it is simple equality, it is called equation. So these are the 4 steps involved. Like, first of all, you should understand the problem, identify what are the parameters and the decision variables, and then use it to form the objective function. So now your answer shows that this is clear to you. Anyone is having any doubt in this particular question or in this one? I believe the things are clear because I divided the things into part. Like here I explained, this is the reading part that was given to you. This is the question. So first you have to tabulate the information. So this is the reading text and this is the video explaining that how it is done. Similarly, there is video for other parts. So just for a quick thing. Any question from here? Anyone is having any question? Anything that is not clear?
Up to here, it's clear.
It's
No,
clear.
no, miss.
Okay. Okay, then if that thing is clear, let's try to work on this. One example based on it, different than what you have done. Just quickly. Suppose you have this example, Blue Ridge hot tubs. This produces 2 types of hot tubs, aquaspas and hydroluxes. Okay, and the information is given in the form of a table that for aquaspa, what are the things we have? Pumps. In aquaspa and hydrolux, both are having one pump. Labor hours 9 hours for aquaspa, 6 hours for hydrolux. For tubing, it needs a 12 feet tubing and hydrolux need a 16 feet tubing. And the unit profit is $350 for aquaspa and $300 for hydrolux. And these are the conditions that there are 200 pumps, 156 hours of labor, and 2,880 feet of tubing available. So use this information to formulate. Take 5 minutes and do the formulation. Come up with the equations. This is which Ahmed? Just give me a minute. I think one student is facing issue in joining the session. We have 3 Ahmed who all are already here. Ahmed Abdul, Ahmed Alawi is here. Ahmed Suleiman Al-Adawi. Just sorry for it.
Ahmed Alawi for her.
Yeah, I'm just checking. Seems he is not able to join the session. Ahmed Suleiman Al-Adawi, yeah, this one. Hopefully, it seems he is logging in from his other account. Yeah. Ahmed, now he is able to. Okay. Now he's leaving. Okay, so in the meantime he joined. Let's work. So just formulate it. I'm giving you 5 minutes. 5 minutes. Read the information and come up with the equation. So tell me what will be the decision variables here.
Maximize.
Okay, maximization because of profit. So it is maximize. So this is the objective. So in any LPP, what we need to know? We need to know objective function.
Sister, how we know it is maximized? How we can know? It
See,
is not
we
clear
are
for me.
talking about the profit. Profit
If we're
related
talking
to
about the
each
profit,
Okay, so profit means if you purchase one, if you sell one, then means if this company sell one of this aqua startup, the company is going to get a
Okay.
profit of $350, whereas for a
Yes,
hydrolux
yes,
it is
oh,
$300. So when we talk
yes,
about
yes, thank you.
profit, it makes let's talk about maximization. Instead of
Yes, I mean,
profit, if it is
if it
cost,
isn't in, yeah,
sorry.
if it is lost, that means buy or something, it will be minimized because
Yes,
we lost money.
exactly. Yes, exactly. And we
Exactly.
are giving money. Instead of profit, if suppose it is cost, then cost also we want to reduce the cost, right?
To
Then
reduce
in
the
that
cost, yes,
case,
exactly. To not lose so much, yeah.
so it will
But
become
because the profit here, so we want to maximize the profit, make extra, increase the profit.
exactly correct. Okay, so this is the objective function. Now, objective function is maximization. So we say that as profit is associated with the thing, with the quantities, with the, we can say, with the type of tubs. This is the objective function. Now I am asking about the second thing. This is first thing that you have got it. Decision variable. Means what you have to decide. What are the parameters? And what are the constraints? Constraints, or you can say restrictions. If you remember what I said, decision variables. These are controllable quantities, controllable inputs. The things that are under your control. Parameters, on the other hand, are uncontrollable inputs. The things which are not in your control. So, what is not in your control here? Means you already used this one. Is this in your control that profit on one aqua spa is 350 and Hydrolux is 300? Is it in your control?
No, because we
What
will
about,
account it, you know. We will get the
exactly,
result now.
No.
The result.
yeah. What about tubing? Is it in your control that this need 12 feet, Hydrolux needs 16 feet?
Yes,
Yeah,
we can
because you have
choice.
already
We can
200.
choice. Yeah.
No,
Yes,
I'm not
we have.
saying that you can select. You can select, yes, you can select that either you want Aquaspa or Hydrolux. But can you
Yeah.
change this that Aquaspa need 12 feet? Can you change this 12 feet to any other number?
No,
No,
no, no,
we
no, no.
can't. It's
You
fixed.
cannot
It's
change.
fixed.
So this is fixed. Similarly, this 16 feet is fixed. This is also fixed, right? Similarly, the labor
Exactly.
hours required to produce Aquaspa, it is 9 hours. Can you change it?
No, it is fixed.
Yeah.
No.
Similarly, the 6 fixed. Similarly, both the model, both the type required one pump. So all these quantities which are numbers which are given over here, these things are fixed. Which fixed means you cannot change it. These are out of your control. So these are known as parameters. Okay, got it? So the parameters are the, say, this box,
So
these
in
numbers.
the schedule, our schedule, where we can put it, those and
Uh,
change numbers.
these numbers cannot change. So we should know, first of all, we should identify that these are the parameters that cannot be changed. Okay. Now, I want to know what are the things that you can change. Means what you can decide. What is in under your
We
control.
can aqua or hydro. That's
Yes,
what we can change. Choice.
absolutely correct. So this is your decision that you want to go for aqua or you want to go for hydro, depending upon this restriction. So this is your what you say, decision variables, that you want Aquaspa, you want Hydrolux, or you want both. If you want both, then how many in number for both? Okay, so these are your decision variables. Type of hot tubs means Aquaspa or Hydrolux. Now it is your decision that how many you want to purchase. So let's say you want to buy X number of Aquaspa and Y number of Hydrolux tubs. Okay. So these are decision variables which you don't know. Now what are the thing left? Parameters also we got. Now we want construct constraints and restrictions. So what are the restrictions? See, we had already used this information. Now we are left with just this information that there are 200 pumps, 1566 labor hours and 2880 feet of tubing available. So pumps, both are using one type of pump, but the total quantity of pumps are 200 total. So if I make it a extra column here. So if I make an extra column, for pumps we have 200. How much is the labor hours? 1566, and the tubing is available is 2808.
200.
Okay, so this is the information that you are having. So you can put this information over here. Now use this information to make the convert it into the mathematical model. So what we started with the hydrolux and aquaspa. So let's say that let X number of aquaspa tubs and Y number of hydrolux tubs are produced by this Blue Ridge. Okay, then what is the, first of all we talk about the objective function, the profit. They say that when it is mentioned in the table like this is $350, it means that one aquaspa tub gives you a profit of 350 unit. So what we are deciding, we are planning. So let's see objective function. Now we are doing the formulation. Sorry, let's first write the decision variables. So what we have, decision variables. So let X denotes the, so what is the decision variable? Aquaspa tub, and Y denotes the hydrolux tubs. Number of aquaspa tubs, and Y denotes the number of hydrolux tubs to be manufactured. Okay, so if this denotes this quantity, then now is it possible to that X and Y will be negative? What I mean to
No,
say
no.
that what will be the minimum value of X? X can be either 0 or it will be say 1, 2 and
Yeah.
any number, right?
Yes.
Yeah,
Is it
because profit.
not profit? Means I mean to say it shows that X means the number. It's let's understand it in this way. If you're going to market to buy, say, let's say for example milk, okay, so what you will do, you will either buy 1 liter milk, 2 liter milk, okay, 3 liter milk, or you will not buy milk at all. Means in other sense, not, it's not fixed about the quantity, you will either buy milk or you will not buy milk, right? So if you are buying milk, we
Great
say
then
it
or
is
equal.
0. Sorry.
Great then or equal.
Yes, so it means either you will buy something or you will not buy at all. So it will be either 0 or something more. So it should be either greater than or equal to 0. So this is how we write. Mathematically, we write it as it is greater than or equal to 0. Similarly, for Y, means either the manufacturer will produce hydrolux tubs or they will not manufacture anything. So it could be 1, 2 or something, but it cannot be negative. So Y similarly can be greater than or equal to 0. Okay, so these are called non-negative restriction. Okay, so this is the very first thing that you have to do after getting the decision variable. So now let's come to the objective function. So as we can see from this slide, the objective is to maximize the profit, right? So one tub will give you a profit of $350. How many tubs you are going to manufacture? X. So the profit will be 350 times X, right? Similarly, one Hydrolux tub gives you a profit of $300. How many tubs you are going to produce? Y. So it gives you profit
300.
of 300 Y.
300. Yeah.
Yeah. So what will be the total profit? Total profit will be from Aquaspa tubs plus the Hydrolux tubs. So it will be 350X plus 300Y. So we write about total profit. So objective will be maximize total profit, and total profit comes from Aqua Spa tubs plus Hydrolux tubs. So for Aqua Spa, how much it is? 350X, and for Hydrolux it is 300Y. Now in a standard notation, the objective function is always written as capital Z. Okay, capital Z. And we say here maximize. So this is your objective function. So we already used this quantity. These numbers are used. Now let's come to the constraints. Remember that we will have only one objective function. Only one objective function. You cannot have more than one objective. Okay, so it should be one objective function. This is done. Decision variables we already decided. Parameters we know. Now we have to use these parameters and restrictions to form the constraints. So which are here. So we have three things: pumps, labor, and tubing. So let's do it one by one. Let's start with pumps. What is given here? One Aquaspa model require one pump. Now you are going to manufacture X Aquaspa. So it will be multiplied with X in the same way how it is multiplied with profit. Similarly, one Hydrolux tub required one pump. So how many we are planning to manufacture? Y. So it needs one Y. So the total pumps required to make X Aquaspa tubs and Y Hydrolux tub will be 1 time X plus 1 time Y. And how many total are available? 200. So what we can do is we can use either all 200 or we can use less than 200. Means we can use 199, 198 pumps to produce these two Hydrolux and Aquaspa tubs. So the constraints here will become constants corresponding to pumps. What it will become? First is 1x for Aquaspa, 1y for Hydrolux. Total pumps available are 200. So we can either use all of them or less than that. Okay. Similarly, the second comes from the labor. It is given that one Aquaspa model required 9 hours of labor. How many we are planning to make? X. So it will take X hours. I hope it is clear why we are multiplying with X. See, for instance, if we are making one Aquaspa machine, it takes 9 hours. How many hours? Two Aquaspa tubs will take? 9 into 9. 9 hours for each. 9 plus 9, that is 18, or 9 multiply 2. Similarly, 3 Aquaspa tubs will take 9 into 3. So we are deciding the number as X. So 9 into X. Similarly, Hydrolux tub, Y Hydrolux tubs will need Y. 6Y number of labor hours, and the total labor hours available are 1566. So it is 9x, 6y. Total available are 1556. So we can either use all the labor hours or less. So it is less than or equal to. This is corresponding to labor. Next is tube. Anyone tell me what will be for tubing? What will be the
12x.
again?
12x
12x
Okay.
plus
plus
16y.
16y
Okay.
less than equal to 2080, 880.
Correct. I hope it's clear to all.
Yes, it's clear.
12x plus 18 or 16? 16. 16y less than equal to 2880. So this is your objective function. So sorry, these are your constants, and hence we are done with the formulation. So when we write what will be the formulated LPP, we say that we use x and y with x and y greater than equal to 0, subject to maximization with these three constants. So we can write it as maximize. We can write MAX for maximization. The objective function Z, which is 350x plus 300y, subject to the constants, subject to these constants, which is x. 1x means 1, x, and 1y means y, less than equal to 200. 9x plus 6y less than equal to 1556, and 12x plus 16y less than equal to 2880, with the conditions that, what are the conditions? This non-negativity restriction. These are important. Don't miss this. Okay? Because this decision variables cannot be negative. It should be always positive. So this is your mathematical model of this given problem. Okay, I hope it is clear. So this is what we talk about in formulation. Okay, so it is
Very
possible that yes, please, sorry.
It is very clear, very clear. Yeah.
Okay, good, thank you. So here we were having two variables, two decision variables, because there are two types of tubs, out of which you have to decide that how many of each type you want to buy. Okay, in some cases you have more than two decision variables. It can be 3, 4, and so on. Okay, so it is possible, and similarly you can have different constraints. Here in this case you were having three constraints because the restrictions were pump, labor, and tubing. Okay, so depending upon that you have the constraints. It could be 2, 3, or 4. Okay, it's not necessary that you always have three constraints, but the thing which will be only one is objective function. Objective function will be only one. Okay, decision variable can be more than one. Okay, similarly constraints can be more than one. It could be 2, 3, 4. Okay, but objective function is only one. In all the linear programming problem, you will have only one objective function. You can see one thing out of these numbers. Now suppose if this table is given, you can directly say, suppose if profit is not written here, still you can directly say that this stands for the objective function. You know why? Because there is no total. For other things, for constraints, the restrictions, you have the total number, means the restriction on the total maximum number of the quantity. But when the things which are associated with the profit, it's not having, or we can say associated with the objective function, does not have anything in the total. Okay, so it's just a like quick, you say, point to notice that which term should go for the what you say, objective function. Okay, what I mean is, suppose it is not given, that tubing thing is not given to you. Instead, they said that you have the uh, and in place of profit, not profit, it should be cost. Okay, let me you okay, if it is say unit cost and it is given that it is $2,000, then in this case you have to use tubing as a objective function because there is no total for that. I hope I didn't confuse you. You got what I'm trying to say. Okay, so it
Actually,
means
you are.
I'm confusing you.
Yes.
Yes.
Okay, let's take another example so your confusion will be clear. I'll take it. Means it is available here. See. So this question is clear, right? Now what I'm talking about is the second one. I'll give you example from here.
The first one, it's clear. The second one,
Okay.
we will wait.
The thing that I was trying to explain is, I'll take an example for it. Then it will be clear to you. Let's go to the post class. Okay. Let's try to work on question number 1. Practice problem 1. Can you read it? Are you able to read it? Then I want you to make a table for this. What I mean is, I want you to put the information in this tabulated form. Or let me just give you the question from here. Let's take this one. Question is on your screen. I want you to keep this information in the form of table. Then I will explain you my point that I was talking about. Take 5 minutes and put the information in table.
Okay.
So now we have to make that information in the table. Yes.
Yes, this is the very first step. Unlike previous
Right.
question, in previous question, the information is already given in the form of table. Now, first step you have to do here is to put the information in table.
Okay, we'll try.
Okay, I'm giving you now 10 minutes. Try it. I'm here.
Miss, please keep it.
What it is, the slide is there. Actually, I just mute because you can see the surrounding sounds in the background. That's why I just mute. So let's begin.
Wait.
Yeah.
Just 1 minute. So what it says, you need to buy some new filing cabinets. You know that it is 10 riyal per unit to buy a cabinet X, which holds 8 cubic feet of files and require floor space of 6 square feet. So you can see that it's from the statement, from the first sentence. What you understand, when we are talking about cabinet X, what are the quantities given? First of all, the cost, okay, and then the files, the volume of files that it can hold, and then the floor space that is required to keep that cabinet. Okay, cabinet is like cabinet or cupboard. You can use the word cupboard. So definitely it needs some space to keep it, right? So these are the 3 things associated with it. So whenever it is always good when you are making a table, when you are preparing a table, keep the information as you read. So as we read here, cabinet X need the cost. It is having cost. Cubic feet, it stands for the volume, and the floor space, which is in square feet. So let's put this in the table. So we have cabinet. This.
Show us, teacher, please.
Yeah, I'm showing. Just 1 minute. And how to do it, right? I'm doing it. Cabinet. We have X cabinet. Okay, so what it is having? Cost. What is the cost? 10. Then volume. How to know it is volume? Because it is in cubic feet.
6
And
cubic feet.
area, which is in square feet. So what is the volume? It is 8 cubic feet of files. It can hold, so you will say that it can hold 8 cubic feet of files. 8 cubic feet, and area, or you can say floor space. Instead of area, you can use the word floor space, which is used in the question.
Area
Which
6.
is 6 square feet. So we'll put it here 6. Now this is about cabinet X. Okay, we have used this information about cabinet X. Now let's read the next line. On the other hand, it is 20 real for every unit of cabinet Y. So it means now they are talking about second model of cabinet, which is cabinet Y. So let's make type here cabinet Y. The cost is 20. Then which require floor space of 8 square feet. Floor space, square feet means area. So here floor space, which is 8 given here. See, the sequence is changed. And hold about 5 cubic feet of files. So it is profit. It is the volume. Okay. I hope up to here it is clear to all of you.
Very clear.
Okay, now let's go to the next part of the question. So we finished up to here. For this purchase, you have been given 140 reals, but don't really have to spend all of it. So what this says, to buy. See, what was the thing? You need to buy. So you have to buy these kind of cabinets. So for this purchase, you have been given 140 reals. So total amount of money available to you is 140. But you don't really have to spend. It means you can use either 140, all of it, or you can complete this purchasing in less. So the cost is this one, and the total amount of money is available to you is 140. So the cost is in OMR. So it will come here in the total. Means you can go maximum up to this, but you cannot go beyond it. Okay. Next, the space in the office has a room for maximum 72 square feet of the furniture. So in your office, you can keep the cabinets that can occupy only 72 square feet of the furniture, not more than that. So this is about the area. So you have restriction on the area. The floor space that maximum can be covered is 72 square feet, not more than that. Okay, because that is the capacity of the room. Okay, so these two things are there. What the next line says, to maximize the volume of files. So you need to read this carefully. To maximize the volume of files that you can store. How many of what model do you need to buy? Okay, so first of all, what is the objective? Maximize volume of files. Volume of files. So you see there is no total here. So what you have to do is it is expected to maximize the volume of files. So objective is maximize the volume of files. And how do you and this is what I was trying to explain you from the previous table. See, although you have cost associated with it, but you are not using it for minimization. Why? Because you have the total budget available with you. Okay. On the other hand, in the question, you don't have anything total for it. You don't have anything here. Right? This is blank. So it means this will be used for the objective function. This is what I was explaining in the previous one. In the previous question, with the profit, you don't have anything in the total. So that term will be used for the objective function. Here, the volume, it is not having any total. So it means it should be used for the objective function. Okay. And anyhow, it is clear from the question as well. To maximize the volume of files you can store. So it means that will be the objective function. This is your objective function. Okay. Now, so what is asked? How many of what model do you need to buy? So your objective is to maximize the volume of file that you can store in these cabinets. You can decide that how many X type of cabinets and how many Y type of cabinets you can buy. So the decision variable will be the number of cabinets of type X and type Y. So we say that by default, as we don't know the quantity, let's assume let it be X and Y. Let small x denotes the number of cabinets of type X, small y denotes the number of cabinets of type Y. So again, either we will buy the cabinets of type X and Y or we do not buy. So it will be X either greater than or equal to 0. Similarly, Y can be greater than or equal to 0. It can be written in combined form as XY greater than or equal to 0. Okay, so objective function, what it will be? Now one X cabinet required 8 cubic feet of volume. So 8 cabinets, X cabinets required AX volume. We'll have 8X volume. Y cabinets, one cabinet required, one cabinet of type Y will have a capacity to store volume of 5 cubic feet. So Y cabinets will be 5Y. So the total volume will be 8X plus 5Y. And what is your objective? Maximize. So we maximize this objective function which we denoted by set. Okay. So we have used this one. Now we will come to the constraints. Constraints means restriction. What are the restriction? You have restriction in the cost and you have the restriction of the floor space. So you have two restrictions, so you will have two constraints. So first constraints for cost. Now one X cabinet is of 10 real. So X cabinets will be of 10X. One cabinet of type V costs 20 real. So the Y cabinets will be 20Y. The total amount available with you is 140. So you can spend either all of it or less than. So 140, so it can be less than or equal to 140. So you have used these numbers as well. Now come to the second constraint, which will be for floor space. One type of X cabinet required 6 square feet of space. We are going to purchase X cabinet, so it will require space 6X. Similarly for Y, it will be 8Y. The total space that can be occupied is 72 square feet. So again, it could be less than or equal to. Okay, with the non-negativity restrictions that XY is greater than or equal to 0. So this is the objective, this function with the constraint, subject to the constraint with the non-negativity restriction. So this is nothing but the formulation of LPP. I hope it is clear now.
Yes, it's clear.
Okay, good. So this is what is mentioned here in your pre-class for this week class. Okay.
The problem is
Yes.
the problem we sometimes we cannot do it the table correctly. If the table not correct, everything not correct.
Yes, that's true.
This is my problem.
Not a problem. This problem will be solved with the practice only. See, that's the reason what I have done is, see, this is a theoretical problem. I have first of all gave this table as an answer. Means what you can do is read the table, try to answer yourself, okay, and then check your answer with from here. Okay. And here see all the explanation, detailed explanation is mentioned in each and every side. That's the reason I have kept these things over here.
When I start the solution, from first step, the table I'm doing not correct. Wrongly.
Okay.
This is the problem.
In that case, you know what you do? Come back to the video. Like I have prepared the separate videos. Like see here. In this video, I explained how to prepare the table first. Means this is the information given to you. How you can convert this information into the form of a table. Okay, so you will now have two examples. One example that we have discussed in the class. Another example is this one. In addition to that, there will be one more example which the links is there in the post-class activity. Then you read this example yourself. See, but this is what I'm saying. Must is you should first watch the video, how it is done. Then practice this question yourself. Check your answer from here. Okay, still if you face that there is something, then go back to video and check what is missing. But still if the thing is not getting clear to you, you can always ask me. Like what is the point where you are doing the mistake? So if you tell me where you are making the mistake, I can help you with the solution, that how you can overcome that mistake. So you have some examples here, and I gave some more additional reading for problems here. And then still if the things are not clear, you can always come back to me. So can you tell me what are the points where you faced problem? Is what actually is the point that you have done mistake? What comes wrong in your table?
And constraint.
Constraint. See, constraints always stands for the restriction. Like in this specific example, let's take the previous one. What is given here? Excuse me. Here it is given there are 200 pumps. So this is the restriction. You cannot go beyond this. You have this many of labor hours. These are the restrictions. You cannot go beyond it. You have this much tubing available. You cannot go beyond this. So this stands for restriction. Means this is comes under the total. Okay, so whatever quantities are having restriction, that only comes under constraint. Like here you have four things: pumps, labor, tubing and profit. But you have restriction only on pumps, which is 200. You have restriction on labor and you have restriction on tubing. Okay, so only these things will come into constraints 1, 2 and 3. Profit, you don't have anything in the total, so it means it will not come under constraints. Similarly, if I take this example, so if you see this one, this is bowl, mug, labor hours, clay and profit is given. Okay, what resources are given? 40 hours of labor, 120 lbs of clay. So labor total is 40. For clay it is 120. You don't have anything on profit. So you have restrictions only for 2. So you should have only 2 constraints. Okay. Is it clear? I hope you got the idea. Of course, you need to practice to get it more, to understand it more better.
We need a
But
lot of
still, like
example.
in case still you didn't understand anything, you can ask me. It's fine.
Miss,
Yes.
can you provide videos for solve this same the problem this one?
Yeah, it is
The
having
model and the models.
it is there in the model. These videos are there now.
I mean videos, yeah.
Yeah, it is there. See, you have a video. Where is it? On which slide? See, this is a video explaining a question.
Yes, we see
This is
that.
also a video.
We saw that.
Okay. Okay.
So these videos are already available. That's what I have done is I am providing the video as well as the reading material so that you have both the things. You can watch the video, and sometimes if you do not understand only from watching the video, you want to read it. I have given the detailed explanation also, like for this particular question, I just first first kept the things in the form of a table, as you can see from here, in the form of a table, and then I write here in detail that what I was speaking now, that one product of type need 2, then x products will become 2x. So this theoretical things is also there. Videos, you will find videos for each and every topic there. I have kept all the videos there. In addition to this, as I told you before, this session is recorded, so you can also watch this session again to go back and check what are the things, what are the points that we discussed, and how to focus on a specific thing to get the resulting output. Okay. I'm sorry, I forget. At what time you said that you need break?
6:30.
6:30. Okay, we have time. I thought I am teaching you in that time. Okay. So is it fine? Shall we continue, or you need just quick break, short break? Sorry?
In the previous class, did you explain something or
No,
based on attendance?
in the previous class, I just explained about the policies, first of all about the course contents, the topics that we have to study here, what are the assessments that we have to follow, and in addition to that, what are our academic policies, and just the basic introduction, how to access the Moodle and all those things. The video recording is available here, so you can check it. Means you didn't miss it, you will find it here in the same group. Okay. In addition to that, I will be make it available in the Moodle as well. Okay.
Miss,
Yes.
I advise all the people to going to the YouTube. There is a lot of solution. They can understand everything by step.
Mm-hmm.
It will they get a lot of information if they not understand in the class.
Yeah, that's what I'm saying. That is okay. You can always go, but still you need to be careful because in math there are different ways of explaining the concepts.
Yeah,
So,
I saw different way.
but still I suggest like first go through the videos that are available there. Okay, and then for further, as Dawood said, you can explore and go through the videos on YouTube. There are a lot of videos. I agree. Okay, but
Also,
it is important first to check what is required in your module. Okay, because operation research or linear programming problem itself is a very vast topic. It is having a different level of problems. So just to be aligned to the learning outcomes of this module, it is important first to know that what are covered, what are necessary things to be covered here, and then you can go through those videos. Yes, it is a very good suggestion by Dawood, like you can go to the YouTube and you will find several videos.
Miss,
Yes.
where we can find a lot of example for this, like this.
More examples, you can click here first. So first of all, go through all the material, then click
I
here.
saw that, but other things.
You clicked here for additional reading.
Okay, this is not click. Okay.
Okay. In addition to that, if you need more, we have a textbook. I have already mentioned the textbook in MIG, Module Information Guide, which is available in week 1 itself. Okay, so you will get the material from there. You will get some more questions from here, Module Information Guide. The book is available here, the textbook name. Okay.
You
Where
can
it is?
find in the library.
Yes, you can. It is available in the library as well. And you can even access the library online, e-library. If you go to e-library, you can find some books over here as well. But the thing is that you have to search it by the topic. Okay, so you can see this is what I explained last time as well. See, if you type here ebook central, so you need to log in with your username and ID, and then you can search the books as per your topic, not only for this module, for any module. So it is in ProQuest ebook central. You can suggest other things from Omran, dissertation, other things, but if you are specifically looking for the books, you can go to the ebook central and search it. So say you say linear programming, search it. So you will find the books, relevant books here. Okay. So you can even download these books. So you don't need all of them. You just need some questions for practice. You can get this one and get few things from here. Like, but again, see, linear programming is involved in many things. So first you should see what are the things into it. Like, let me just see the table of contents. If I read online, you can read online or you can download the PDF chapter, and thing is possible. So here, so linear programming, model and examples. Yes, you can go to page. So you can always first look at the contents. So linear programming problem, linear programming modeling and examples. So yes, they are talking about the modeling. So we'll go to page 7 there, where they are talking about the modeling. First chapter. Of course, the different authors will have different way of representation. So don't get worried about it. This is the general form of a linear programming problem. Okay, and then they started directly with the solution. Just a minute. They talked about the inequalities, equations, introduction, maximization and minimization. Okay, so in this book, it is more of solution oriented. Okay, let me just quickly check if it is having. See, it's done here. Agriculture mill manufacture feed for chickens. This is done by mixing several ingredients: corn, limestone, alpha. Okay, so this is more generalized. So this is what I'm saying, like linear programming is a very vast topic. So it is having very advanced level concepts as well. So to understand this one, first you should have the basic, like what we have done today. So this, if you directly try to read this one, it's going to be difficult for you. Okay, so that's why I suggest first of all go through the material that is available to you, and then you can go for the other one. Like see, now it is given over here. Capital budgeting problem. You have this information here. You can use this information to formulate it. again it's going to be it needs some more basics to the questions that we have done already. So I suggest first to go to what is available here, and okay, you have this MOOC course. Okay, you just click on this link, go to this MOOC course for the better understanding. Here you have to click on this link. And this course you will have more concept about the topic. So when you read this one, so see what is available here. It will give you the brief idea about this course. Okay. So I'm going to provide you all these things. Let's first check what is here in this one. You have in the post class activity, as I said, link for additional reading. Let's see what is it. Linear programming problem and its mathematical formulation. So here you will find a lot of example. Okay. Here it is as per our requirement, like it starts from the basic and then it goes to the difficult level. So you can read it from here. See. Now this thing is there. Now you want to know the solution. You can click here and get the formulation. So you will get the questions from here. Okay, so you can always solve these questions, and in case these questions are not clear to you, you can come back to me. So you can type the different types of LPP, diet problem, manufacturing problem, constraints, and all those things, like say diet problem if you have. Sorry, this is different. What's wrong with it? Earlier it was free. You don't need to log in. I don't know what happened to this one. It is free. It is not paid one. Okay, not a problem. Just see this side and solve those questions that I already showed you. These questions, see, solve these questions. Then I will provide you some more questions in case you need more. Okay.
Okay.
Okay, then let's move to the, shall we move to the next thing? So these are the things available in the post-class activity. In addition to this topic, now you need to prepare for the next week class as well, the topics that, okay, what you will do after the formulation. After the formulation means once we come up with these equations, like in the previous example, we come up with this equation, right? This formulation. Now, what to do with this? What to do with this? Thing is that our question is not solved. We want to know that how many type of aqua spa tubs or hydrolux tubs should be purchased. So we need to find what is the value of x and y. So to find this x and y, we need to find the solution of this linear programming problem. So there are several ways of finding the solution. So the very easiest way is graphical way of finding the solution. Okay, so that is what we are going to begin with. But the restriction for the graphical way is that you can use the graphical way only when two variables are involved. Because when you have two variables x and y, you can plot one variable along x-axis, another variable along y-axis, and get the solution, because it is easy to visualize. But when it comes to 3 variables or more, in that case, graphical solution is not possible. Graphical solution is not suitable, okay, for 3 variables or more. So we will use graphical method only for 2 variables, which is mentioned over here in this one. So what are the steps that need to be followed to go through to find the solution by using graphical method is mentioned here. So what is it? What you have to do is you have to plot each of the constraint as an equation, and then you have to plot it in a graph, because equation in a graph represents a line. Then you have to find the feasible region and the corner points, and then compute the objective function. Okay, now I know that you need a quick revision to understand how do you draw a line. So for which, what I have done is I have prepared small videos explaining the steps. First 2 steps listed over here. First is consider each inequality or constraint and equation, and then plot it as a line on the graph. So these 2 short videos are available over here. Watch them. This will give you an idea how to come up with the graph. Then in the next step, I gave you how to find point of intersection of 2 lines. Okay, so this is what I want you to go through for understanding the graphical method. So this is, you need to do it today. Once you're done with this one, what will happen is, just one moment. Once you're done with this one, in next week class, we will see how to find the solution by using graphical method. So again, this is the pre-class material that is available to you, which is having some definitions that I want you to go through. That what do we mean by solution, feasible solution, optimal solution, unique solution, unbounded solution, and so on. And then how do we find the solution? So again, similar to what I have given for this week, I gave you the reading material, this example solved with the steps. Okay, then there's a video explanation of doing this, of solving this question. Okay, step-by-step procedure. Then this is again another video explaining everything, graphical method from the beginning. Okay, then these are some conditions of the graphical method that we will discuss in the next class, because this is topic related to next week classes. So again, you have videos relevant to each and every case. Okay, because in graphical method, we can categorize depending upon the region that we are getting, the types of solutions that we have. So this thing is mentioned and kept it in the terms of video and questions. So I recommend, as you have done today, answer these questions as per your understanding, and then we will give the, we can always discuss this thing in the class. Okay. So now what is left for you today is go through the this thing, the post-class activity for this week, and understand this basic. Like first of all, first thing that you have to do is those who had not solved all the questions from pre-class material, solve all the questions again for formulation, because what I want is before we move to the next topic of graphical solution, the formulation should be clear to you. Okay, so once the concept of formulation is clear, solve all the questions yourself. Okay, and then only, yes.
It is important to solve it.
Yes,
It is
for your
any marks
understanding.
for that?
Sorry?
Any marks for that?
For this solution, no. But based on these solutions, we are in future weeks, in the coming weeks, we are going to have online quizzes, in-class quizzes, okay? And there will be marks for that. So that's why it is important for you to practice this, because if you didn't practice this, you will not be able to answer those questions.
How to
Okay.
do that
Sorry?
online? How to do the online quiz?
Yeah, I will be explaining you that how it will be available to you and how you have to answer it. So the sample is like how you got it in the pre-class material.
Okay.
Just let me show you. See, in the pre-class material, I have put some question here. What are the decision variable, right? How did I ask you from here? This was the question. Then based on it, there was a question. What are the decision variables? You have to answer. Okay. Similarly, I explained a video, and in the video you have the questions in between. Okay. So in the quiz, you will not get the video and question, but you will get a theory, the question like this. And then I will ask you, okay, for this example, first of all, what is the objective function in this one? So you can say that maximize the profit. Okay, then how many constraints will be there in this question? So how you know that? So unless until you understand the concept, you will not be able to answer those questions. So, or in other words, what I can say is, suppose I gave you this question and I will ask you questions related to this example. Like, okay, tell me what will be the decision variables? So you have to answer those things. Means there will be option, multiple choice. You have to select one. Okay. Sometime I ask you, okay, I gave you it will be containing questions of the form match the following. Like I will give you different constraints and equations. You have to identify that which one of them is objective function, which one of them is in the constraints. Objective function is maximization or minimization. What are the non-negativity restrictions, and so on. Okay, so the set will be there with you. Clear? Am I clear?
Yeah, very.
Okay, so now I suggest you to go through this post-class activity, complete from pre-class and post-class activity, complete all the questions related to the formulation, and then go through this graphical. And this videos, what I recorded, it is required because I know that it's been a long time that you have studied how to plot a line. So it is important to understand. Like for example, if you have a line 2x plus 3y is equal to say 12. I want to draw it here. So how do we do this? So to draw this as a line,
We have to divide.
We need to find at least 2 points, because if we join 2 points, then only we will get a line. Okay, so we are looking for 2 points that lie on this line. Right? So how do we get those 2 points? 2 points means we need the value of x and y, which is satisfied by this. So there are many ways of doing it. For me, the easiest way is I make a table. Okay, and what I will do, I will write here x and I write here y. So in this equation, if I put x is equal to 0, what will happen? If x is 0, what will happen here? 3y, 0 plus 3y equal to 12. This gives me y is equal to 12 over 3, that is 4. So I get it, the value of y as 4. So it means if x is 0, y is 4, this equation is satisfied. So one of the point is 0, 4. Okay, it's not necessary that you use 0, you can use any value. The reason I have used 0 is because if I use in place of x 0, this term becomes 0 and it's easy for me to do the calculation. Okay. For instance, sorry, it should not be here.
Miss,
4 should be
this
here.
one
4
for
should be
the
here.
class or for this class?
Sorry.
This will be for this class or for next class when we know when
This
we learn
thing
how
you need to know. Yeah, this thing you should know before coming to the next class. That's the reason I'm explaining it now. So at least your time will be saved and you will understand it before you come to the next class. So you can spend your time in understanding more about the graphical method. Similarly, say if I put x is equal to 2, what will happen here? So it will become 2 times 2 plus 3y is equal to 12. So see here I have to solve it. 4 plus 3y equal to 12. This gives me 3y is equal to 8. This gives me y is equal to 8 over 3. So I have to do this many calculation to get this value. I don't want to do this. So what I will do instead of this, I make the point means this is correct. Not wrong. But the easiest way, if I put y is equal to 0, I can directly from here get x is equal to 6. Okay, so it's up to you. Use any method to find 2 points. The main purpose is find 2 points so that you can join them and get the equation of line. Okay, so this is the concept which is explained here in this video. And the step 2 is how to draw these lines on the graph and how to find the point of intersection. So what does it mean is, if you have these 2 lines, say this is line 1 and this is line 2, and you want to know this point. What does this point stands for? What are the coordinates of this point? So how to find this? It is mentioned over here. So all these things are basics which are required for the solution of a graphical solution of a linear programming problem. Okay, so you need to go through this post-class material as well as the pre-class material before coming to the next class. Okay, any doubt?
No,
It's okay.
no, doctor. Thank you.
Okay.